Hi guys, welcome to our discussion. I'd like to encourage our members to kindly go to YouTube, search for our channel, subscribe, and then engage us on the comment section. You can also follow us on social media from the different videos that we are doing. I'm always putting a link and some of the descriptions of our channels there. So in this case for today, we're going to look at multiplication of polynomials and some of the rules which are going to be, of course, applicable. Now, in this case, to multiply a monomial or a polynomial, we're going to use what we call a distributive property. Which we have discussed in some of our videos, but in this case, I'm just going to give an elaboration of just a summary of what this concept of distributive mean. Now, suppose we have two variables which are added together for A and B, and then we are told that these ones are multiplied by 2. We're going to multiply 2 with these individual variables which are appearing in the brackets. So therefore, we'll get this is the product as 2a plus 2b, implying that this 2 has been distributed and been given as a product whereby this coefficient for 2 is appearing on A and B. And therefore, this property of being distributed is what we refer to as a distributive property. Now, this is going to be the case whereby we're going to do a multiplication for monomials and polynomials. And in this case, I'm going to just have this one done so that we can just give a specific example for this. So suppose we have a polynomial which is given as 3x squared, and then it's given as into, sorry for that, 4x plus 5 minus 3x squared. So if we try to look at this specific polynomial, we're going to see that it has been multiplied by this specific term. Therefore, we're going to use that distributive property in order to find the answer to that. So we are going to do direct multiplication for this, whereby this every factor here is going to affect each term that is appearing in the bracket. So the first term is going to be a product over these two, which is going to be, we multiply the respective coefficients, numerical coefficients, which is going to give us 12, and then this x going to give us 3, plus this is a 15x squared, and then minus this is 9x to power 4. So that is going to be the product that we're going to obtain after applying that concept of a distributive rule. Now, if move ahead, we're going to look at also at the application for polynomials. This was a monomial which is being multiplied by another polynomial in this specific order. So if you have what we call polynomials, let's try to see how they are going to behave. So if we have x plus x squared, and then this one is multiplied by 2x minus 3x cubed. So let's try to look at those polynomials which are containing 2 terms and 2 terms respectively, how we can be able to do an operation for them. Now in this case, we're going to see that as we said from our first example, that each term in the first polynomial multiplied to every term in the second polynomial. We're going to see also in this case that we can be able to do a multiplication and see which are some of the terms that we're going to obtain from this specific case. So this is going to be 2x squared, and then so each term x multiplied by this, x multiplied by that one, is going to be negative 3x to power 4, and then plus this is 2x to power 3 minus this is 3x to power 5. So if you try to look at this specific product, it's going to appear as such, and therefore we can be able to do what we call I'm just checking for these terms. So this is going to be the product of that specific multiplication, having applied the concept, the general concept that each term in the first polynomial is multiplied with the second every term in the second polynomial to obtain that. Now there are some specific cases we're going to see whereby we're going to see that some polynomials have special products. For example, we try to give a plus b as a square. This is going to give us a squared plus ab, okay, plus 2ab plus the square of b. So that is the first case which we're going to have a special product for those polynomials. And then if we have a minus b as a square, this is going to give us a squared minus 2ab plus b squared as the second special case for that polynomial. And then suppose we have a product of these two terms, these two expressions for this polynomial for addition and subtraction. Then we're going to see that this is going to give us the square of a as the first term and the square of b as the second term. And this is going to form the third special case for these polynomials. And then next we can have another one which is of course a minus b being multiplied by a squared plus ab plus b squared. This is going to give us a cubed minus b cubed. Now suppose we have an addition here for a plus b, and then multiplied by a squared plus ab plus b squared. This is going to give us a cubed, and then this was a minus, and then minus b cubed. So this is going to form the fourth and the fifth special terms respectively. So you can just do a cross check to confirm whether the products that I'm giving here are coinciding, and from that, in case we find a variation, just put that one in the comment section so that we can be able to do a rectification. So in this case, those are some of the special products that we're going to find in multiplication of polynomials. Now, of essence for us is to understand the concept that for polynomials, each term in the first term, of course, is multiplied with every term in the second term. And then number two, this particular concept obeys the distributive properties, just like the example I'd given initially for a plus b. And lastly, we have a special type of products, which basically are going to assist us to simplify operations that are concerning the polynomials which I've listed on the board. So I hope that that one is going to assist us, and it's going, of course, to open for us ways in which we are going to find out how we can be able to do what we call factorization of polynomials. Now, as you can see, we are doing a multiplication. In some instances, it's going to require us to find the factors which have been multiplied in order to find this product. So that basically implies to the concept of factorization, which we are going to look at in our next video. So that is it for now. Bye. Catch us in our next video. God bless you.